carbonyls and +2 charged. Okay, then +2 charged metals, and I mean properly this type of charged metals and the metal zero oxidation state, metal +1, metal +2, this type of metals is most preferred to the bind with the carbonyls and the formation of their metal carbonyls and their metal carbonyls. So based on the number of n is based on the number of metal atoms, so we can classify that what is the, for example, M1 type of carbonyls are there. M1 type of carbonyls is the mononuclear carbonyls. M1 type is the mononuclear. M2 type is the binuclear. M3 type is the trinuclear. Okay, these are the carbonyls, and M4 type also is there. These are the low nuclear carbonyls. LNC, low nuclear carbonyls. Some carbonyls are 5, M5 also is there. Some carbonyls are M5 also is there. M5 type, M6 type, M7 type, M8 type, M10 type carbonyls also is there. These carbonyls are known as the HNC, high nuclear carbonyls. High nuclear carbonyls. In this high nuclear carbonyls are referred to the formation or formation of the one structural form, that is called what? Clusters. That is called what? Clusters. So now we can discuss about the different types of carbonyls are there, and how to their properties, how to what is the properties, and how to prepare the carbonyls, how to prepare the carbonyls. So this the total is there. So means metal is contain the vacant orbital. Metals are contain the vacant orbital. The CO is contain the lone pair of electron. CO is contain the lone pair of electron. Okay, lone pair. CO is contain the lone pair of the electron donate to the metal. Means the formation of the sigma bond or sigma donor. Carbon is acting as a sigma donor. At the same time, metal is contain the vacant means field electrons also, field electron orbital also. In the metal is donate a pair of electron to the ligand. Okay, that is a pi acceptor. The CO is acting as a sigma donor and a pi acceptor. Okay, based on this, that is acting as a different types of binding modes are there. Different types of binding modes are there. Let us we can explain one by one all points. So first we can discuss about the how to prepare the carbonyls, how to prepare the carbonyls, and what is the properties of that. What is the properties of that? There is a preparation of metal carbonyls. Preparation of metal carbonyls. So it means observe first reaction. N number of or X number of metals is bind with the Y number of COs. X number of metals is bind with the Y number of COs. The formation of MX COY type of carbonyl. MX COY type of carbonyls. You can observe here. So X number of or N number of metals. N number of metals is bind with the Y number of CO. The formation of MnCOY type of carbonyls. Direct bind with the metal. Direct, we can apply the small conditions. The condition also not required here. So you can observe here means some other iron is bind with the carbonyls. Iron is bind with the carbonyls. The temperature is at 200 degrees centigrade and atmosphere also 200 atmosphere. Okay, that is formation of pentacarbonyl iron complex. Pentacarbonyl iron complex and high pressure synthesis. The different types of methods are there. So common preparation method is metal is directly bind with the carbonyl. Direct method is metal is directly bind with the carbonyl and the formation of their suitable metal carbonyls. Okay, so here different types of preparation methods are there. Different types of preparation methods are there. Nickel cyanide is bind with the carbonyl. The formation of nickel tetracarbonyl. Okay, and okay, so these are the different types of carbonyls are there. Okay, means iron is bind means the lower lower carbonyls to the formation of higher carbonyls also. Lower carbonyls means LNCC, low nuclearity carbonyls, is bind with one another and the formation of high nuclearity carbonyls. That is more means higher carbonyls also form. So based on that, we can classify the carbonyls are different types are there. We can classify the carbonyls are different types. What is the types of that? Mononuclear carbonyls. Mononuclear carbonyls. Mononuclear means only one is metal is there. For example, iron is the metal. Iron is the metal. Okay, that is bind with the 5 COs and the formation of FeCO5 is the carbonyl. This is what mononuclear. Only one metal is there. 5 COs are bind. Okay, and nickel cyanide is react with the 4 carbonyls, the formation of nickel tetracarbonyl. Okay, this is this type of carbonyls. So many carbonyls are there. Okay, we can apply some conditions. Here we can apply the temperature. Here apply the pressure. Here apply the pressure. Okay, some conditions. Temperature is the condition. Pressure is the condition. Sometimes pH is the conditions. So different conditions are there. Based on the conditions, metal is directly bind with the carbonyl in the formation of their carbonyls. Okay, in the first prepared carbonyl is the nickel tetracarbonyl. Okay, in 1985, so 1885. Here is the 1885. The first prepared carbonyl is the nickel tetracarbonyl. Okay, and what is the geometry and how to formation of the complex? What is the donor nature? What is the acceptor nature? We can explain here. Okay, means what is the properties of the nickel carbonyls? Okay, the formation of nickel carbon. Okay, then what is the property? What is the geometry? What is the metallic nature? Means what is the means magnetic nature? Different types of explanations are there. Can explain the mononuclear. The particular is the nickel tetracarbonyl. So nickel is surrounded by the 4 carbonyls and the formation of nickel tetracarbonyl. What is the geometry of these carbonyls? What is the geometry of these carbonyls? Means we can explain the properties of metal and we can explain the properties of approaching ligands. That is the carbonyls. Okay, here what about the carbonyl? Carbonyl is the sigma donor and a pi acceptor. Carbonyl is the sigma donor and a pi acceptor. This is acting as a nucleophile. Okay, what about nickel? Nickel is contain the that is acting as the electrophile. Some electron deficient means vacant orbitals are there. Vacant orbitals are there. In that vacant orbitals are occupy the electron from the COs. How many vacant orbitals are there and what is the properties of that? Okay, we can explain here. What is the atomic number of nickel? The atomic number of nickel is 28. What about the electron configuration? The electron configuration is the argon 4s to 3d8. Argon 4s to 3d8. We can distribute the electrons in the orbits. For example, what is the d orbital is there? D orbital is contain how many electrons? 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there. And what about the s orbital? Also contain the 2 electrons. P orbital is the vacant. P orbital is the vacant. S also contain the 2 electrons because the here the central atom is acting as a neutral. There is no charge on the central atom. So in this condition, how many vacant orbitals are there? Only 3 vacant orbitals are there. So in the internal, some changes or rearrangements are occur in that central atom. What is that? Here paired electrons are there now. Paired electrons. Okay, means s orbital is contain 2 electrons and here d orbital is contain 2 unpaired electrons. So in this one unpaired electron pair with this electron. Okay, and this electron also pair with this electron. Okay, means all electrons are pairing takes place. All electrons are pairing takes place. So after pairing the electron, after pairing, what is the electron distributions? Okay, this is the what is the distribution of electrons? How to distribute the electrons? Like this. How to distribute the electron like this? Means what? This is the d orbital, s orbital, p orbital. Okay. So d orbital is contain already 8 electrons are there. D orbital is contain already 8. What is the configuration? D8 configuration is there, and these 2 electrons are jump in this orbital. Means all orbitals are plus 2 electrons are enter in this orbit. In that condition, how many electrons are there? All electron orbitals are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the electrons are fulfilled in the d orbital. And what about the vacant orbitals? One s orbital and 3 p orbitals are there. These all orbitals are undergoes to the hybridization and the formation of sp3 hybrid orbitals. The formation of sp3 hybrid orbitals. In that condition, nickel is contained for sp3 hybrid vacant orbitals. The orbitals are arranged in which manner? Tetrahedral manner. Which manner? Tetrahedral manner, like this. Okay. So after arrangement of electrons, okay, the remaining vacant orbitals are undergoes the hybridization. Remaining vacant orbital undergoes the hybridization, and nickel is contained. This is the one of the sp3 hybrid orbital. This is another sp3 hybrid. This is another sp3. This is the another sp3. Okay, like this. Small nodes are there, not big node. Small nodes. These all are sp3 hybrid orbitals. All are vacant orbitals. And what about the d orbitals? All d orbitals are fulfilled. Some electron field orbitals also is there. That is not showing here. Okay, in these 4 vacant orbitals are approaching the 4 COs, are approaching the 4 COs, one CO, donate the electron pair. Okay, another CO, donate electron pair, another CO, electron pair, another CO, electron pair. That means these all COs are approach the central atom and the formation of tetrahedral geometry of nickel. What is the geometry? Tetrahedral geometry. Okay. What about the coordination number? What is the properties? Now we can explain the properties of this complex. Which type of properties are there? The central atom is nickel is undergoes to the sp3 hybridization. Coordination number 4. Coordination number 4. Okay. Tetrahedral geometry. Tetrahedral geometry. And what about the magnetic property? This is the diamagnetic. This is the diamagnetic. Why? Because of there is no unpaired electrons are there in this complex. In this complex, orbitals are not contain any unpaired electrons. That's why that is exhibit the diamagnetism. What is the mean by diamagnetism? The diamagnetism is the the complex. We can insert the magnetic beam in the complex. That is repulsed to the magnetic beam. That is repulsed to the not attract the magnetic beam. Repulse the magnetic beam. That type of complex are what? Diamagnetic complex. That type of complex are what? Diamagnetic complex. Okay. What about the EAN of this complex? EAN is nothing about what? EAN. You know the EAN? That is the EAN is nothing but effective atomic number. EAN is nothing but what? Effective atomic number. Effective atomic number. EAN. What is the EAN? The equation of EAN is the Z minus oxidation state plus 2 into number of ligands or number of ligands into 2, number of plus number of ligands into 2. This is the equation. Z is nothing but what? Atomic number of the central atom. Then what about the oxidation number in that central atom? Okay, and the number of ligands into 2. So we can calculate in this complex nickel tetracarbonyl. What is the EAN? So nickel tetracarbonyl is the complex. Nickel is tetracarbonyl. Okay, 4 COs are there and 4 ligands are there. Nickel is there. Nickel is contain. What is the atomic number? 28. What about the oxidation state? 0 oxidation state. Plus, how many ligands are there? How many ligands are there? 4 ligands are there into 2. that is equal to 28 plus 4 into 2, 8, that is equal to 36. Okay, effective atomic number. We can count the all electrons of this complex. We can count the all electrons of this complex. The electrons is the 36. So these 36 electrons are near or similar, means exact to the what is the krypton electron configuration. Krypton also the 36 atomic number. Krypton is the 36 atomic number. Krypton is which group element? Krypton is a zero group element. Krypton is a zero group element. Okay, we can calculate the EAN of those complex. In that complex is the follow EAN rule, means those complex total electrons are similar to the, means what, zero group element atomic number. The follow the EAN rule, that complex are more stable. Not follow that, compare with the other complex and less stable. That is the EAN, effective atomic number. Means in this complex obey the EAN rule. Obey the EAN rule. That means this complex is a stable complex. This complex is a stable complex. Okay, so like that. Okay, that is the complete explanation of, is a complete explanation of the nickel tetracarbonate. Okay, then what about the other complex? Also is the, what about other complex is the FeCO5. FeCO5. Okay, iron pentacarbon, iron pentacarbonyl. What about the properties of this complex? What about the properties of this complex? Okay, so means iron is contained, so similar mononuclear, all similar. This is there, and one of the chromium CO6 complex is there. Here all metals are what? Neutral. Metals are what? Neutral. Okay, so here FeCO5, this is the trigonal bipyramidal geometry. The hexacarbonyl chromium is the octahedral geometry. This is the sp3 D2sp3 hybridization. So this is the dsp3 hybridization. So different types of hybridations are there, and based on the coordination number, or based on the approaching of ligand, Okay, that much of Wicket orbitals are contained in the central atom, and the formation of the metal carbonyl complex. The formation of metal carbonyl complex. Okay, so that is the mononuclear. What about the binuclear? Binuclear means two metals are there. It means two metals is bind with the Y number of COs. The formation of two M2 COY complex are formed. COY means Y is the number of Y is the number of Y is the number of carbonyls. Means for example, Mn2CO10 is the binuclear carbonyls. Cobalt to CO8 is the binuclear carbonyls. Mn2CO10 is a binuclear, and CO8 different types of CO2. CO means cobalt. This CO means what? Carbonyl. Okay, carbonyl dinuclear means CO2, cobalt to CO8 type of carbonyls are formed. Okay. What? Increase the number of metals, the metal bond also increase the number of metals, the metal bonds also increase. So like that, here binuclear also is there. Okay, binuclear carbonyls. What? CO2, cobalt to CO8. Next, another complex is there. So Fe2CO9, Fe2CO9 is there, and Mn2CO2 is there, CO10 is there. Okay, different types of is there. So here Fe2CO, just wait, CO2CO8 is exhibit the two different types of complex, means geometry is nothing but terminal mode of the CO, mode of the carbonyl in solid state. One type of binding mode is there. In the liquid state, one type of binding mode is there. In the solid state, some ligands are acting as a bridged COs. In liquid state, some ligands are acting, all ligands are acting as a terminal. Okay, all ligands are acting as a terminal. That is about the binding mode of carbonyls. The binding mode of carbonyls. Can you explain? The binding mode of carbonyls. Just 1 minute. Okay. That is a binuclear carbonyl clusters. Okay. So means that is metal metal bond is compulsory is there. Metal metal bond is compulsory. How many metal metal bonds are there? How can you explain that? We can explain one carbonyl. That is what uh, Mn2CO10. We can explain that Mn2CO9. Okay, CO10. Manganese to CO10. We can explain that. Okay. For example, Mn2 CO10 is the binuclear carbonyl cluster. What about the properties of that? We can explain properly individually. Okay. So what about the manganese here? Two manganese are there. What about the manganese? What is the atomic number of manganese? Is the 25. What is the electron configuration? That is the argon 4s2 3d 5. Argon 4s2 3d 5. Okay. So in that condition, manganese are contain how many vacant orbitals? How many vacant orbitals and how many orbitals are contain the electrons? Okay, okay, manganese. What about the manganese status? First one manganese. Okay, sp orbital. Okay, so how many electrons are there? That is the d orbital is contain 5 electrons. Okay, and the S is contain 2 electrons. This is the status of manganese. This is the status of manganese. Okay, so how many vacant orbitals are there? Each manganese are contain 3 vacant orbitals. But here how many carbonyls are surrounded? 10 carbonyls are surrounded. That means that each manganese are contain 5 vacant orbitals. Each manganese are contain 5 vacant orbitals. In that condition, some internal changes are occur. What is the change? First, this electron are pairing here. This electron are pairing here. This electron are pairing here. Okay, means after shifted the electron, after pairing the electron, what is the electron distribution pattern? Okay, so here 1 2 3 4 5 6 7 7. Okay, then one s orbital is there, one 3 p orbitals are there. In this condition, how many vacant orbitals are there? 5 vacant orbitals are there. How many is there? 5 vacant orbitals are there. For the manganese are contain 5 vacant orbitals. The 1 2 3 4 5. Another manganese also is there, no? Another manganese, that is also same status. Another manganese also same status. That means that is also contain 5 vacate orbitals. That is also contain 5 vacate orbitals. Okay. What about the electrons are distributed in that manganese? Second manganese is the 1, 2, 3, 4, 5, 6, 7. This is the status of two central atoms or two manganese metals. So here, what about the 10 COs are there? Each CO donate electron pair 2, 3, 4, 5. One manganese are approach the 5 COs. Another manganese also approach the 5 COs. Means what? Here 1, 2, 3, 4, 5. Okay. What about here? This manganese is contain one unpaired electron is there here. Here also an unpaired electron is there. Both electrons are bind with the manganese bond is there. Manganese bond is there. Okay. That is the structure of manganese. Means here what is the each manganese are undergoes the sp3d hybridization and dsp3 hybridization and one unpaired electron is d2sp3 hybridization and all the 6 hybrid orbitals are contain one orbital is the unpaired electron is there, 5 is the vacate is there. Total 6 orbitals are generated. D2sp3 hybridization. One D2sp3 orbit is contain the unpaired electron, remaining all vacant orbitals. Okay, in that all vacant orbitals are up, approach the lalma approach the 1 minute నాకు కొంచెం చిన్న ఒక 2 నిమిషాలు ఇది ఉంది పని ఉంది మళ్ళీ కనెక్ట్ అవుతాను ఒక్క 5 minutes వెయిట్ చేయండి మళ్ళీ కనెక్ట్ అవుతా ఐ విల్ కనెక్ట్ అగైన్ ఆఫ్టర్ 5 minutes ఓకేనా స్మాల్ వర్క్ ఇస్ దేర్
Okay.
Okay, sir.
Okay, this is the structure. We can draw the structure also. What is the structure of that? The structure of that is the Mn one bond is formed, and this Mn is contain the 5 COs. This Mn is contain the 5 COs. This is the structure of this is the structure of. You can observe the individual structure of that individual observe structure of that. So this individual is the octahedral. This individual is the octahedral. Okay, D2 sp3 hybridization. Why? Because of here CO is acting as a strong ligand. CO is acting as a strong ligand. Okay, all electrons are pairing is takes place. All electrons are pairing takes place. Okay, you see nothing about the here the binuclear carbonyl cluster of binuclear carbon Mn to CO10, Mn to CO10. Okay, like that we can binuclear, trinuclear. Okay, different types of carbonyls are there. Okay, so all carbonyls can. Then put the another slide. Okay, binuclear this is a trinuclear also is there. Trinuclear means Fe3CO12 means and
Sir,
M3CO12 type of carbonyls are there. M3CO12 type of carbonyls.
sir, sir,
M3CO12.
Praveen sir.
M3CO12 type of carbon is a trinuclear carbonyls. Trinuclear. Okay. In this M3CO12 carbonyls. Okay. Here, what about the M? M is equal to iron, ruthenium, and osmium. Iron, ruthenium, osmium. The trinuclear carbonyls. Okay. In this trinuclear carbonyls, the metal-metal bond, three metal-metal bonds are there. Three metal-metal bonds are there. Here you can observe that two different types of geometries. Different types of geometries. What is the different type of geometries? Some carbonyls are connect with the bridged manner. Some connect with the bridged manner and means Fe3 CO12 Fe3CO12 ఇక్కడ Fe the two in this 12 carbonyls 2 COs are bridged 10 COs are terminal. Okay, in this ruthenium and osmium carbonyls all 12 carbonyls are terminal carbonyls. 12 are terminal means linear carbonyls. Terminal means linear carbonyls. Bridged means that is connect the two metals. Okay, how can you find out the bridged and terminal carbonyls? That is about the we can apply the IR spectra of that complex. IR spectra of that complex. Okay, that complex IR spectra give the stretching frequency. We can use the IR spectra. We can find out the functional groups are organic complexes. Functional groups. CO is the functional group.
Sir,
And
notes मिल
different
जाएगा
groups are there. Based on the functional group, we can give the spectral peak. So CO is a free, that is give one type of peak. CO is a terminal, that is give one type of spectral analysis. CO is bridged, that is give the one type of spectral analysis. Okay, the CO is a free is there, that is a 222 nanometers centimeter inverse their range. That is a terminal 2143 is their range. At the bridged, that is the 2000 to 1800 centimeters. That is the different types of binding modes are there. Different types of binding modes are there. Based on that here, based on that, so the okay, so Based on that, here different structures are there. Means metal means M3 means ruthenium and osmium. All carbonyls are terminal carbonyls. 12 carbonyls are terminal carbonyls. You can observe this Fe3CO9 structure. Fe3CO9. These two carbonyls are bridged. Remaining 10 carbonyls are terminal. Here iron also we can arrange the two different types of binding modes. Means one iron is bind with the all terminal COs, and two irons are bind with the two bridged and three terminal COs. Okay, that is can stability purpose their structural aspects. Okay, and tetranuclear carbonyls. Tetranuclear carbonyls. That is also some different metals are there. Iridium carbonyl, tetranuclear carbonyls, rhodium carbonyls, and osmium also. Iridium, rhodium, osmium. This also the tetranuclear carbonyls. You observe here. Okay, and cobalt also the formation of tetranuclear carbonyls. Cobalt also the formation of tetranuclear. And what about this cobalt? So that is in solid state and liquid state. That is the two different types of carbonyl clusters is there. Okay, and here that is a low nuclear carbonyl cluster. Low nuclear carbonyls, they are class undergoes the low nuclear carbonyls. Low nuclear carbonyls. Okay, so listen all of you, some work is there now. సో కాబట్టి నేను క్లాస్ కొంచెం వైండ్ అప్ చేస్తున్నాను. అర్జెంట్ వర్క్ ఉంది. ఇంకో హాఫ్ అన్ అవర్ ఉంది క్లాస్, కానీ
సార్
కొంచెం వర్క్ ఉంది, నేను క్లాస్ వైండ్ అప్ చేస్తున్నాను.
सर ये नोट्स मिल जाएगा क्या प्रवीण सर? सर